Today's topic is CMOS settings. We looked at this a little bit when we were booting up the machine to see what was inside of it. Today we're going to look at this in more detail. So when people say CMOS, what do they really mean? Maybe this is an old term. Some people call them setup settings, but that seems kind of redundant. So CMOS settings is what they used to call it. And what this refers to is the initial startup settings or the configuration for your computer. These are things that get set before the operating system gets loaded. So anything that has to be put in place before the operating system gets loaded are usually put in the setup program for the PC. You have a PC right next to you, and you can try some of this stuff out when we do our scavenger hunt. So typically, to access CMOS, there's a special key combination. It will be displayed very briefly when the machine is cold booted. What's a cold boot? Anybody know? You unplug it, plug it back in, and then turn it back on. That means everything gets reinitialized. Now, there used to be a lot of BIOS companies, and each one had a different key press. You figured they'd standardize this, but they don't. So here's some examples of all the different things to get things working. Today, the ones for our computers are F2. So F2 is a common one. But again, there's no real standard here, so everybody uses a different key. So these are all the settings a BIOS needs. What's BIOS? Anybody remember the definition there? Basic input-output system for the PC. These settings are stored in CMOS. Now, you remember the CMOS is that place where the clock is, and the battery keeps that alive. So it keeps the clock going, but it also remembers these settings that we make, because you don't want to have to reset this every time you turn the machine on. So it's more than just the clock it's keeping alive, it's these settings as well. And then there's really no standard version of the setup program. It just varies depending on what kind of computer you have. Even varies from computer model with the same manufacturer, because these computers are a little bit different. The menu structure is, there's no consistent way of showing that. There are CPU settings. Say you want to disable 2 of the cores, or say you want to overclock it a little bit. You can do that in the CMOS settings. If there's any integrated devices, you can enable and disable them. Like the ones on our desk, I would imagine the VGA port is either disabled or available as a second monitor, because we have another sound or video card in it. So we have a video card that's not being used right now, and we have another one that's in a PCI Express port. And the question is, do you want to disable the first one, or do you want to use it as a second monitor? I'm not quite sure. You can also do settings based on which USB ports you want to enable or disable. So all of those integrated devices, you should be able to turn on and off. Now these computers on our desks have a serial port on it. It's 9-pin, it's male. So that's a COM port or a serial port. So it gives you the base I/O addresses, the DMA channel setting, the interrupt request line, whether or not it's enabled or disabled. And the machine supports up to 4 COM ports, even though there's only 1 serial port on the back. There's also settings for memory. You can set the speed of your memory. Say you want to overclock a little bit, you can speed that up. There's Parity. This allows your memory to be a little bit more picky about what it reads. And there's 2, well, I guess perhaps 3 types of parity. Let me just show you what a parity bit is. So here you have your byte. One zero one one 1010. Okay. But you have this extra bit at the end. 1 2 3 4 5 6 7 8. And say we're doing even parity. How do you say parity? It's this, not this. Okay, so parity, P-A-R-I-T-Y. Okay, and what even parity means is you count up the number of switches that are on. We're using even parity, so we say, okay, there's 5 bits that are turned on. Is that even or odd? It's not even, so you put a 0 here. Okay. If, say, one of the bits was flipped, so 1, 2, 3, 4, 5, 6, that's even, so they would put a 1 there. Okay? And it's kind of an error checking thing. If one of these things gets stuck, then the parity bit is not going to match up. It's not great. It's not great because if 2 of the bits get stuck, they could still pass the test. But if you want to make sure your memory is a little bit safer, you could turn on the parity bit. Typically, you don't see this except for in servers where it's really important. You can also set the boot sequence. Should I boot from the CD drive before I boot to the hard drive? Things like that. And then there's also passwords so that people can't mess with the settings. Because there's a rule in computers when you have a public lab like this, is if people can mess with it, they will. Okay, so you need a way of making sure nobody messes with it. Say you're troubleshooting things and the machine keeps getting hanged up and you say, I just want to disable some of the devices on the hard drive or on the motherboard just so that I can try to figure out which one's messing up. So you disable maybe the PCI slot or the Wake on LAN setting. What Wake on LAN does is, Ms. Rouse, who's technology facilitator here, she needs to install, say, a bit of software on all the machines in the lab. So you used to have to go from machine to machine with a disk and install it. Not very efficient when there's 650 computers in the school. What she'd like to do is, from a centralized computer, wake up all the computers in the lab, have them do the install, and then shut them all down again. Well, then that begs the question, how should she do that if the computer's shut off? And the answer is she can turn the computer on over the network card. Actually, the network card doesn't shut off. Everything else does, but the network card stays alive. Why is that? So they can hear when Ms. Rouse says, okay, it's time to turn your stuff on so I can install new software. So she has full control of our lab because of the Wake on LAN setting. Say you don't want your machine to be woken up or it's a security hole, then you can shut that off. And that's one of the settings in CMOS. Here's the boot order I was mentioning earlier. Typically, hard drive comes first, then the CD drive, maybe a bootable flash drive, and finally it gives up and goes to the network. Hey, does the network have an operating system I can load? So those are the typical order. You can change this order. Say you want the flash drive to come first because you have a Linux distribution you want to run on your machine at home. You can switch the boot order so it'll go to the flash device. If it's there, it'll load the operating system from that. If not, it'll go to the hard drive. So this ordering can change. Bootable CD-ROMs, our machines now don't even have CD drives on them anymore. Why is that? Well, everything you can download over the internet, and that seems how you install stuff nowadays. So needing to have a CD is not that important. Way back when, the bootable CD-ROM specification is called the Torrito specification. This is kind of one of those cultural, historical type things. And I always wondered why it was called the Torrito specification. And the story behind it goes like this. Down in California, there's a chain of restaurants called El Torrito. And so all these engineers were sitting around having lunch one day at El Torrito, and they started scribbling on napkins what they want this bootable disk format to look like. And they kept referring to it. Hey, remember a couple of weeks ago when we were down at El Torrito? We came up with this idea. Let's do that thing. And so they started working on it, and everyone just called it the El Torrito specification because that's where the original engineers, when they first started talking about it, had lunch. So I thought that was a rather humorous story. Maybe I'm the only one. So sometimes, and this is the scary part, sometimes you buy your new computer, and now it's a couple years old, and you go get the newest graphics card, and you plug it in, nothing happens. Isn't it supposed to download the driver? Your computer can't even recognize that new piece of equipment. And that's a problem. Because when the BIOS gets written, it can't foresee 2 years from now what kind of devices are going to be coming out on the market. So there's no way for it to know what kind of card that is because it didn't exist when the BIOS program was created. So how do you get around this problem? Well, you have to update the BIOS. So there's a mechanism for doing that. Now you have to be careful. First, you have to figure out who's the BIOS manufacturer and what version of the BIOS they're running. The way you can figure that out is go Start, Programs, Accessories. I usually just right-click on the folder and say Properties, and it'll take you to the right spot. You have to be careful here because you have to figure out the BIOS manufacturer. You go to that site, you've got to get the right one Because if you flash your system with the wrong BIOS, then the machine no longer works. You have to send it back to them and they have to reinitialize it. You can't do that yourself. So you've got to make sure you get the right version from the right place. If you load the wrong one, your motherboard is unusable. You just chunked your motherboard, at least for a while. So the process typically is you got a new piece of equipment, you plug it in, it doesn't recognize it, so you go and get the BIOS, which is updated. You flash it onto the new machine, and then it recognizes the new piece of machinery, and off you go. But you've got to make sure it's the right one. So typically it's off a flash drive. There's a little bit of flash memory. The CMOS program is written in Flash, actually. And that's where flash disk came from, is CMOS disks, or CMOS chips. They just kept improving on that until finally they could do it in large quantities. And it used to be really expensive, but now it's cheap. Sometimes you're able to update directly from the website. I don't know how that's supposed to happen, but you can download it and it will do it automatically. Now, when you go in and you make a change from the default of your CMOS settings to something else, you have to write that down, something that stays with the machine. I'd put it on a Post-it and put it on the side of the machine. Or I have a little log I have with each computer, because I work with lots of different computers. So each one has a little log file, and I write down things that I change, because invariably what will happen is the battery will die, and then you get a new battery and come back up and your computer won't work. And you go, well, I remember how to do something 3 years ago to get this to work, but now I forgot what it was. And now I have to go through the troubleshooting and figure it out again. Okay? There's no operating system. You can't print out the settings. There's no way to do that. So you're kind of, if you don't write it down, then you're going to be hunting around for settings when you have to fix it 3 years later. What I've given you in class is a CMOS settings scavenger hunt worksheet. And your job today is to look through the setup program on the machine in front of you, and then kind of like a scavenger hunt, you need to go and look for each of these settings and write them down on your form. While you're doing so, you might have the computer to your right open up, and there's some technologies that are used on a motherboard might be interesting to read about, like rapid start, and there's all these trademark type of things that you might want to look at. But the reason why I'm having you do the scavenger hunt is first I want to know what sort of settings are available in CMOS, but also familiarize with some of the new technologies coming out from Intel. So anytime I say in the worksheet a new technology from Intel, you should look that one up and see what it means. Why is it good? Why does it differentiate their product from somebody else's? That way when you go down and get parts, you know what you're asking about, that you did your homework. Okay? So that's your homework, is to do your homework. So how do you start the setup program? Well, you shut down the machine or restart the machine. As it's coming up, start spamming the F2 key. Okay? Don't hold it down, because that might fill up the keyboard buffer. But just tap the F2 key while it's booting up, and it should take you to the setup program. Are you going to be able to change any of these settings? The answer is no, because they're password protected. But you are going to be able to see them and see what options are available. All the computers in the school that people are using have been locked down, and the reason is because if people can mess with it, they will. All right, so that's our assignment today. If you need help, raise your hand. I'll come around and give you a hand.